One of the things we've had requested for a long time, wanted to do, support engineering activity of lifting and turning. And the solution goals, well, first and foremost, model lifting and turning equipment and everything that's required for that, and including allowing for finite element analysis for the external software programs to do their structural integrity and that kind of thing.
And so the ultimate end goal, we're partnering with a number of shipyards and some software partners as well who specialize in finite element analysis, AT and Altair are their names. But this is an NSRP project, and the purpose of it was to support the engineering activities of lifting and turning through the automation of information sharing between ShipConstructor and FEA or FEM software programs, leveraging the functionality of EnterprisePlatform's Publisher and Publisher LT. So it really has a lot of moving parts to it, but we're pretty proud of how it turned out so far. And so you can go to the nsrp.org website and you can read more about the LiftShip project, but I'm just lifting this off our good friend Pat David's notes on there. But this project intends to leverage the knowledge of existing FEA workflows at the shipyards as the basis for an approach to automating large-scale lift preparation and analysis, and to provide mechanisms for generating appropriate lift package production drawing deliverables. So this technology area to be investigated in the scope of this project includes providing a means to generate a lift package output drawing from ShipConstructor to describe the lifting configuration and the required components, including bills of material. We then wanted to export the model identified in the lifting arrangement, including structure, weights, and centers of gravity of those associated objects. We then wanted to export the lift configuration and components so they could be automatically meshed for FEA analysis, including lift objects as well as force vectors. And so really SSI's team was focused on those steps 1, 2, and 3, and then we get into a few sort of external steps, but definitely integrated into what we were focused on doing. And that is, so our partners were identifying deformation limits to flag the appropriateness of the lift based on material properties and shipyard requirements. Perform those FE analyses on the meshed model and provide feedback as a range of acceptability for shipyard engineers to determine the feasibility of a lift plan. And finally, produce simplified output to describe the lift configuration appropriateness and the anticipated effect on lift subject, i.e. deformations. So the target audience for this, so who can or should use this product? On our team, we identified 3 to 4 core types of users. We've interacted with those types of users on weekly teleconference calls as well as some face-to-face meetings over the past year. And so basically, you have ShipConstructor type users who maybe specialize in modeling, lifting and turning equipment and force vectors right in ShipConstructor. Maybe they've done this in AutoCAD or just on the back of an envelope calculations previously. We have engineering CAD managers who would leverage the power of EnterprisePlatform Publisher or Publisher LT to create lifting and turning work packages to pass data from ShipConstructor to external third-party FEM or FEA software programs. Finally, you've got finite element model analysts who will then import lifting data such as weights, sensors of gravity, extents generated from ShipConstructor using XML and step part data using EnterprisePlatform into those external third-party FEM and FEA software programs, and thereby creating lifting models and analyses capturing stress and strain relationships to pass on to lifting and turning shipyard engineers who will then specialize in the calculation, logistical planning, and safety operations surrounding a lifting and turning exercise. So some of the key deliverables and benefits, I mean, there's a number of parties in the United States as well as us in Canada who participated in this. It was a collaborative effort. Those are some of them in there, and started in May of 2018 last year, and it goes through to April of this year. It's a 1-year project. It's an NSRP investment of $1.1 million and an industry investment of $1.7 million. So some of those key deliverables or benefits, This is all from the website on the nsp.org. Achieve a technology readiness level of 8. Demonstrate the technology in a shipyard production environment, which we're planning mid-February at a number of shipyards in the southern Gulf Coast of the United States. And then one of those ultimate goals is to reduce those hours and costs associated with lift arrangement drawings generation, FEA mesh generation, FEA solving and analysis, FEA reporting and decision making, distortion correction, temporary structure reduction, and managing rigging assets, and lifting lug reuse design production. And one of our points of contact is there included. And I'll attach this to the webinar slide deck as well later, as Patrick Davids has mentioned. So where can you find it? If you're in ShipConstructor, in the production tab, you're going to find these icons in the ribbon, or on the command line. You can create a lifting component, you can create a lifting vector. If you've made any stock changes to lifting components, we've included an update lifting components command, and that should update it within from the catalog to your drawing, as these lifting components and vectors live in assembly drawings, I should mention. They do not reside in the database aside from the actual stocks themselves. So that's something key and important to keep in mind. You can also anchor lifting components to other pieces of structure, equipment, and unanchor them as well. Standard ShipConstructor behavior there. Also, one of the steps used in the overall workflow is to insert bombs, and that's just found under the SC Assembly menu production tab. And you choose lifting component bomb or lifting vector bomb. So this is just a key summary. We've added that ability to add lifting components and vector small drawings. That's been our focus at SSI, and you can export them using Enterprise Platform operations to produce step, just in XML files, TSV files as well. It's a format supported, which allows for finite element analysis calculations to be made by those external software programs. So lifting component modeling and lifter vector modeling and assembly drawings as mentioned. And there's a summary of the Enterprise Platform export operations. So I'm just in an assembly drawing in the training project, Unit 20, in Unit 2, so it's assembly drawing 202. And here I am lifting and jigging a pad eye in that drawing. So you just use normal jigging procedures you can use ShipConstructor snaps to place it in your drawing. And I've got the OPM up as well, and we'll get back to that in a second here. And so subsequently there I'm showing the creation of a lifting vector. So you can, I'm just, standard jigging practices again. So rather than doing it on the fly quickly, I'm gonna just place it first, and then I'm gonna modify it directly via the OPM. You can change the color to make it stand out more, and default's white there. And I can change the arrow size. There you go. Make it bigger. You can change the text direction as well. I have it currently as a center parallel. And this is the key point. This is just a string where you can enter the magnitude in magnitude units, so that's just completely user-defined. And so lastly, I can change the style as well. If the text is not showing up, I can change that just using the AutoCAD text, or styles command rather. So make that more visible. And so finally, maybe I want to align my lifting vector better with the center of gravity of that lifting component. So I can just do that directly. It's grabbing the CG point there, noting it elsewhere, and then I can just re-enter that in the vector properties there via the OPM directly. So that just lines it up a little bit better. So as you can see, I'm just changing the values there directly to have a better align with the center of gravity of that lifting component. But this is just a little video showing how one imports BOM XML and LiftShip Enterprise Platform operations in Manager. And so you can see we have Enterprise Platform LiftShip BOM for part info, lifting components, and lifting vectors for BOMs. And here I'm just adding some full part type data. So, and ShipConstructor itself. So in the model space, here you have in Unit 2, so assembly drawing 0200 in the training project, you can, change colors, you can add lifting vectors and lifting components here to your art's content. And then if we switch to assembly drawing layout, you'll notice here you've got your assembly stage BOM and you've got a lifting component BOM, and those lugs and paddis are listed in there, and you've also got your lifting vectors in a BOM if you wish. And those just, any changes you make can be updated as per usual using update BOMs command. So as I was saying, we included material properties, bill of material, BOM and assembly drawings, and lifting vector force information. And so one thing to note, you do need to have a proper mechanical profile set up. Enterprise platform operations do use AutoCAD Mechanical for that, so that's a requirement if you're introducing this to your users. And we also, it's worth mentioning, using SC export twig for curved plates, there's a separate workflow for that so that it meshes out more readily, quicker, and easier.